So welcome students. In this video, let us look at how to determine whether 3 points are collinear using section formula and how to determine the nature of a quadrilateral using section formula. So if you are given 3 points A, B, C, so how can you determine using section formula that these 3 points are collinear? So the simple trick is we assume that the point B divides AC in the ratio lambda is to 1. So lambda is to 1. So let us take this as x1 y1, this as x2 y2, this as x3 y3. So x2 y2 will be equal to lambda x3 plus x1 by lambda plus 1, lambda y3 plus y1 by lambda plus 1. So x2 y2 is equated to this. So from the first equation you get some value of lambda, from the second equation you get another value of lambda. If these two values of lambda are equal, that means that B divides AB in certain ratio. If lambda from x coordinates is different from lambda from y coordinates, that means this point does not divide AB in any particular ratio. That means B lies outside AC. So if you get the same values of lambda from the first equation and the second equation, that means A, B, C are collinear. If you get different values of lambda from these two equations, that means that B lies outside the line segment AC and B, A, C are non-collinear. Next, if you are asked to find the nature of the quadrilateral formed by 4 points A, B, C, D, by 4 points A, B, C, D. So we have already seen how to use distance formula to determine the nature of quadrilateral. Now let us see how to use section formula. So the first condition is if diagonals bisect each other, that means you find the midpoint of AC and the midpoint of BD. The midpoint of AC from the midpoint formula, the midpoint of BD from the midpoint formula. If you get the same point, if diagonals bisect each other, then it will compulsorily be a parallelogram. If diagonals bisect each other, it will automatically become a parallelogram. You don't need to check anything else. If in a quadrilateral diagonals bisect each other, it certainly becomes a parallelogram. Next, the more additional conditions that get satisfied, the more specific the figure becomes. So diagonals bisect each other, diagonals bisect each other, and diagonals bisect each other, and the length of diagonals is also equal. That means it becomes a rectangle. Now diagonals bisect each other, if AC is not equal to BD, that means the diagonals are not equal but adjacent sides are equal. AB is equal to AD, this becomes a rhombus. The figure becomes a rhombus. Next, diagonals bisect each other, the diagonals are also equal. Diagonals bisect each other, diagonals are equal, and the adjacent sides are also equal. This becomes a square. So as you go down, the figure becomes more and more specific. If all the 3 conditions are valid, then it is a square. If diagonals bisect each other, the adjacent sides are equal but diagonals are not equal, then it is a rhombus. If diagonals bisect each other and diagonals are equal but the adjacent sides are not equal, then it is a rectangle. If adjacent sides are equal, it becomes a square. If just diagonals bisect each other and no other conditions are satisfied, that is, diagonals are also not equal, adjacent sides are also not equal, it means the figure is just a parallelogram. So this is how you categorize the nature of quadrilateral using section formula as well as distance formulas.